Hey you. Who, me? You. Yeah, you. Have you ever wondered what came first, the chicken or the egg? Nah, I'm just kidding. Have you ever wondered why a teacher chooses you more than other students? Is it because I'm ugly? No, it's not. Is it because they want to? Maybe. Have you ever thought, if I am closer to the teacher, do I have a higher chance of being picked? Let's use two different classes for this example. Class set 1 and class set 2. You might be curious as to what those stars in each set stand for. Well, those stars stand for the position that the teacher stands in, which is the position we are testing. Now we have to measure from point A to point B. Point A stands for the teacher's position. Point B stands for the squares, or the students' desks within the class. We have to measure from point A to point B, and we calculate the inches between those two distances. Here is the list of the inches for each position in class set 1. Now here are the measurements for class set 2. If you still don't understand how I calculated the distance between point A and point B, then here is another visual representation. And following this is a recording of how I measured the distance. Okay, so from here?
235.
235? The very next thing you need is the height of the teacher. For these two examples, two teachers volunteered their heights for this experiment. The teacher for class set 1's height is 5 feet 8 inches, and the teacher for class set 2's height is 5 feet 3 inches. The next thing we have to do is convert both heights to inches. For class set 1, in inches, the height is 68, and for class set 2, the height is 63 inches. Now we have to subtract both heights by 4 inches because people's eyes are not on top of their heads. So teacher 1's height is 68 inches. Subtract 4 inches from that and it's 64 inches. Teacher 2's height is 63 inches. So subtracting 4 from that would give you 59 inches. Now that we have both the teacher's height and the distances between point A and point B, we have to find the percentage. To find the percentage, we have to divide the eye level by the distance and multiply by 100. This will give us the percentage rate of whether or not being closer to the teacher will increase your chances of being picked versus somebody that's farther from the teacher. Now here is a better visual representation of the percentage zones. Dark blue stands for a higher percentage chance, and light blue stands for a lower percentage chance. Simple? Yes. Not everything is simple though. The farther you are from the teacher, the better chance of you not being picked. But if you're closer, you have a higher chance of being picked. Now let's throw in a couple of factors that might change the percent. Does a person's height and location affect the percent? In this picture, let's assume that person A is 6'2" and person B is 5'4". Now let's also assume the following: desk length, average length extension span, chair height, desk height, and chair back height. Step 1. Identify what we know. So person A is 6'2". Person B is 5'4". The desk height is 28 inches. The chair back height is 16 inches. The average leg span distance is 25 inches. The desk length is 35 inches. And the floor to chair height is 20 inches. Step 2. We need to find out how much of the human body sticks out of the chair. To find that, we have to find out how much of the human body is actually sitting down and covered by the desk. To find that, we must add the average leg span distance and floor to chair heights together. The next step is to subtract the height of the body that is under the desk by the total height of the person. Step number 3. Now we set up the shape of our problem, connect points from each person's head and from the distance between the desks, and fill in what we know. So far, this is what we know. Person A's height sticking out of the chair is 29 inches. Person B's height is 19 inches. And the average length of the desk entirely is 35 inches. We need to know the last missing side so we know what the difference is between the two people. To find the missing length, we need to split the shapes into two shapes. After we split the shapes up, we fill in what we know. The next thing we do is we use the Pythagorean theorem to solve for the missing side length. So we know that the triangle is 10 by 35, so we just fill in the blanks. 10 squared plus 35 squared equals c squared. After everything, we find out that our answer is 36.4 inches. Now that we have the distance between the two persons' heads, let's place them in a random area in class set 1. Let's place person A and person B in the third row. The desks in that row are these percentages. Now the next step is to add the distance between point A and point B to the height distance between the two persons. This will give you the percent change for person B. For person A, subtract the height distance by the distance between point A and point B. The reason you add and subtract the differences is because even though the persons A and B are not going closer or farther away from the teacher, you add and subtract because you have to recognize the height difference and who is sticking out more than the other. Now that you have the new differences calculated, you just plug it back into the equation. Eye level divided by distance times 100. Here are the new percentages. That's it. Really? Really. So whenever your teacher chooses you more than others, look at the problem from a math point of view. You have a high percentage of being called on if you are closer to the teacher. Well, goodbye now. Results may vary.